Okay, today we're going to do a lab called Investigating Energy in Falling Motion. And this goes with what we did yesterday, when yesterday we learned to do calculations with conservation of energy. So it says when an object such as a ball falls, it accelerates and acquires kinetic energy or energy of motion. It does not reach terminal velocity. It acquires its maximum velocity and therefore its maximum kinetic energy just as it hits the ground. At that point, its motion is stopped and is compressed. The kinetic energy is momentarily converted to potential energy or stored energy. This potential energy is then converted back to kinetic energy as the ball bounces back. No ball will return to the exact height from which it was dropped because some of the kinetic energy is converted to other forms of energy, such as heat, when the ball strikes the ground. According to an important principle known as the law of conservation of energy, however, the total amount of energy does not change. In this investigation, you will describe the motion of a bouncing ball and examine how the ball demonstrates the law of conservation of energy. By plotting graphs, you will also examine how well different substances retain their original energy. So we're going to have 4 different types of balls. And first of all, if you look at this diagram, what we're going to do is we're actually going to put the ball at the top of the meter stick. So we're not going to put it in the picture. It shows it like between 95 and 96. What you're going to do is you're going to put the bottom of the ball that lines up with the top of the meter stick. And this is going to be the 100 centimeter mark, and down here is going to be the 0 mark. So when you drop the ball, it's going to bounce. So then what you're going to do is you're going to look again at the bottom of the ball, and you're going to record where the first bounce is. And it's going to be hard because the ball's moving, so you're going to approximate. So let's say for the tennis ball, it's 55 centimeters. Obviously, we can't read to 100th of a centimeter and use the correct significant figures for measuring for that instrument because it's going to be moving. Then you'll do the second bounce, the third bounce, the fourth bounce, and let's say it doesn't bounce 6 times. So if it doesn't bounce, just put a horizontal line through it. If it bounces 8 times, you're only going to record the first 6 values. Okay? All right, so you're going to do this for all 4 balls. So that's your data. What you're also going to do is you're going to mass the balls. Now, even though you're going to be using a triple beam balance that measures in grams, so you want to make sure that you convert this to kilograms. When you're looking, when we're doing our calculations on the back, you also need to make sure that you convert your centimeters to meters because we need to have everything in our standard units. Okay. So after that, we have a graph for each ball, and you're going to do the height in centimeters. You're going to do the bounce and the height in centimeters. Now, these are going to be a best fit curve. We're not going to do a bar graph. We're not going to connect the dots. We're going to do a best fit curve. Then we're going to do our calculations. This is exactly like the homework that we did yesterday in class. So it says calculate the total energy of the ball at 100 centimeters. Okay? Then, now remember, you need to convert this to meters. So then when you're answering these questions, this needs to be in meters. And then it says at the same point, what's the ball's potential energy? This is where we're going to do our calculations for conservation of energy. The total amount of energy remains the same. So we can write out our entire equation that PEI plus KEI is equal to PEF plus KEF. And then we can see, well, what's 0? We can also do MGHI plus 1/2 MVI squared is equal to MGHF plus 1/2 MVF squared. And then when it says what is the speed just before it hits the lab table, well, this is what we did yesterday, and we remember when we solved for VF. Okay? So that's what we're going to do here. Then you're going to answer the questions in complete sentences. Okay? We're not going to write a one-word answer. One of the things we have to do in every class is we have to practice writing, so this is where we're practicing our writing, so we're going to write it in a complete sentence that answers the question that's being asked. Okay? And the rest of the lab is just answering questions. So there's critical thinking questions. And that's it.